Okay, this is Mr. Ritter again. Here we go. 1.2, the path to discovery for the scientific method, right? So, what we want to talk about today is trying to identify the steps that make up the scientific method. Now, I know you guys are all about this. And one of the things is you've talked about this since probably you were in kindergarten and stuff like that. And so we'll go over it just briefly. I got a really cool video to show you. And then we're going to talk about the meteorite impact hypothesis. And I'm just going to probably talk about that more than anything. It's a theory on really how we developed and where we got, where we came from. All right. So when we talk about the scientific method, basically, this is a way for us to organize scientific research. It's logical, it's organized, and it allows us to get the information to people so people can have a dialogue. It's a way of coming to conclusions and answers and building on other people's research. And so the first thing that we really have to do is state the problem, right? So what is it that we want to look at? And a lot of times, almost every time, without exception, we probably have a pretty good idea what the answer is going to be. And so people always have this vision of the scientific method going, oh, I'm going the this, and it's just a wild guess, and it's usually not. Scientists really do have a pretty good idea where it's going to go, and they're testing it. So the first thing we got to do is make an observation. We're using our senses to gather information about the real world: touch, taste, smell, feel, hear, see, making measurements, right? And so that's the big thing. And so we're observing, we're gathering the information using measuring tools. We're measuring these things, and this allows us to get to the information. And so a measurement is comparing to a standard unit. And what's interesting is like a foot, right? And meter in the metric system. We don't use a standard unit in science, like foot, inches, mile, etc. But we do in everyday life. And so what we have to do is know them all. And back when I was a kid, in the 70s, they tried to push in the United States to go to total metric system. And you had a lot of people who just didn't want to do that. They were people who are set in their ways. And really, the metric system is such an amazing thing because it uses a base of 10. And so by being able to use a base of 10, it's very easy to convert. Instead of for us, like there's 5,280 feet in a mile. Well, yeah, we can do definite or dividing and multiplying and add and subtract and all that. But for the metric system, you're simply moving a decimal place over to the right or the left, and it just is really easy to do. Um, and think about the different units that are out there, right? So, how about this? Horses are measured in hands. What? And what? How big is a hand? Or when I was a little kid, my grandpa used to measure his farm in rods and chains. What's a rod? It's like 33 and a third feet. And what's a chain? And so um, that was a that there were a lot of different measuring systems out there, and the metric system is a scientific way of measuring things, and it works really well. Now, and sometimes you can't use the metric system, like how many meters is that board? Well, it's probably how many feet and how many inches. Okay, so the next thing that we're going to do is form a hypothesis. You know, what is the solution? And again, we probably have a good idea of what's happening, but we've yet to prove it. Then we test and 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 we test all over again. Now, how many times should we test? I don't know. But you do it enough times to verify that this is the right solution to this question. And so we call that experimentation, testing a hypothesis. And you want to only have one variable or one thing that you change at a time. And the rest is controlled or control variables, right? And so the independent and dependent variable, independent, what did you change? What is different? So if I were to measure what killed my fish in my fish tank, hate to say that, and I would say, okay, I think it's carbon dioxide. And so I would have 5 fish tanks all lined up, and I would have some with carbon dioxide, some with not. And it would be the exact same amounts of the gases. And we would see, okay, yeah, how many fish died? And then we would know, hey, yeah or no, this is not what killed your fish. Feeding would help too. So a variable is that thing that we change, the independent variable. The dependent variable, not to get you confused, dependent is what we're measuring. So in my fish tank that I had put carbon dioxide in, carbon dioxide would be the independent variable. The dependent variable, what we measure, would be the number of dead fish, which my crawdad would like. This is called a controlled experiment. We are setting up to test one variable. All right, once we're done there, we've got to state the conclusion, and either it's good and we accept it, or it didn't work out so well and we reject it. And so we're able to determine or come back and start all over again. Now, once we've done that, we've got to share our results. And if we don't share our results, then the information doesn't go out to the people, and it's as if the experiment never happened. You may know it happened, but now other people don't get to build upon their work or your work, and you don't get to set the conversation. So it's vital in the scientific community about sharing results. And some are better at it than others, depending on if it's proprietary knowledge or if they're trying to set up some patent or something like that. But for the most part, in order for a research to be correct, it has to go through the scientific process of being vetted by other people just like yourself or themselves to be able to say, hey, you did great work, or I just don't see it. So why share? Those are pretty much the reasons. We test and retest and check your work, and people say yes or no. What I'd like you to do at this time is to stop this video and log into Moodle chapter 1.2 and go to Which Do Cars Hit More, Turtles or Snake by Roadkill, Mark Rober. Mark Rober's an incredible guy. He is a PhD scientist for NASA. He retired from NASA at a very young age and started making these videos. The dude is stinking brilliant. He's an amazing guy. Mark Rober, turtles or snakes, which do cars hit more? I'll pause and you guys can watch that. All right, welcome back. So exciting. So let's just review real quick. We talked about identifying the steps that make up the scientific method and explain how meteorite impact hypothesis was developed. So we did not talk about that. I'll talk about that now. So meteorite impact hypothesis. The hypothesis was that a giant meteorite, about 2 miles round, wide, whatever you want to call it, slammed into the Yucatan Peninsula 156, 160 million years ago. With the Yucatan Peninsula is down by Mexico, slams into it out just a little bit off the coast and causes this giant explosion to take place, ejecting all this molten material, on fire material. And if it wasn't on fire, the moment that it went up into the sky and came back through the atmosphere, it caught fire again. So we had all this raining down of material that was on fire, and this giant cloud of dirt that engulfed the earth for about 6 months and caused this complete darkness. And so the meteorite impact hypothesis is really what they thought killed the dinosaurs, and they had to go about proving it. And so they went through a lot of different methods, and what ended up happening was they found this layer called the KT boundary, and it was this layer of dirt that was everywhere on the globe, and they were trying to put it together, and they finally were able to date it back to a certain time period, which is about 160 million years ago. And as they did, they noticed that everything fossil wise was dying, and they didn't see any fossils after that. And eventually they came to the hypothesis that this giant meteorite basically wiped out all the vegetation, blotted out the sun from the sky, rained down this incredible massive fire of material, and killed all the big megafauna on the planet and a lot of other things too. And so the reason why the dinosaurs died was this giant meteorite. And it wasn't until not too long ago that they were able to find the impact location right where they said it was going to be. And they were using sonar and saw the ripples on the ocean floor where this material had solidified and where this meteorite had impacted. And so the thing about the meteorite is meteorites have uridium in it, which is not native or natural to the Earth. And so they were able to trace this back by using this hypothesis. And so that's the meteorite impact hypothesis. Way cool. Not so much for dinosaurs, but for us to kind of learn about, yeah, pretty cool. So with that, I hope you guys have a fantastic day. Thank you so much for being amazing. Keep doing great things. And also, make somebody's life better just because you're here. Take a chance. So have a great day. Thanks so much for watching. We'll talk to you later.